Professor, Stage 2 at PG Department of Business Administration, Sambalpur University. Dr. Sahu has completed a project of rupees 4 lakhs funded by ICSSR New Delhi. He has a passion for research and he has been a resource person for a number of workshops and FDP programs held in India and outside India. He has published 39 research papers in reputed national and international journals, including Scopus and ABDC indexed journals, and also authored 4 books to his credit. Dr. Sahu has been awarded with Global Teacher Award 2021 by AKS Education Awards for accomplishing excellence in education service. Thank you very much, sir, for accepting our invitation to be a part of this program. Thank you very much, sir. Now we will start, sir.
So thank you all. So good evening to all of you. I'm audible clearly to all of you. I'm audible clearly to all of you. Can anyone respond?
Yes, sir.
Yes, sir.
Yes, sir.
So in this workshop, rightly it has been mentioned that we are all the core learner. We are all the core learner. So that is the reason I invite you all to take active participation in the workshop, because the very name is workshop, not the seminar where we are the active or passive listener. So what I mean to say is, I have some scope to learn from you also. So you know very well the virtual platform make us redundant in most of the cases. So in any way you can interact with me, maybe in the chat box, maybe in any other way, or the moment I am completing one concept, you can break me and ask me some question, even if I will give you some time after every concept to have the discussion. So let us open the platform for a mutual learning so that I can learn from you also. So in this context or in these expectations, let me start. So the PPT is visible to all?
Yes, sir. Yes, sir.
Yes, sir.
So I hope all the basic things from the very beginning has already been completed, starting from basics of SPSS to the basic operation of SPSS. And I hope all of you have come across either MPhil or coursework of PhD or basics of statistics or basics of research methodology at any point of your career. And having this background that you have the basics of the research methodology or statistics that is to be applied from very beginning, let me clarify that the statistics and research methodology are two extreme ends. Application of statistics is there in the research methodology, but do not make it synonymous. Most of the time we are making the mistake of making the synonymous of statistics with research methodology. Anyway, so the main aim of my saying is having this assumption you are all introduced to the basics of statistics or basics of research methodology and basic application of the SPSS software in the initial 5 to 6 sessions I am starting. And the structural equation modeling, I will go through all the details, do not worry. But in general, in a layman point of view, what is the mean? It is a multivariate statistical technique, because the simultaneous equation we are solving, simultaneously statistical equation we are solving, hence it is a multivariate statistical technique. And the moment we are saying multivariate statistical technique, what statistics plays the role, which role the statistics plays here, what exactly statistics in the context of multivariate. So we know from nowadays from the standard 8-9 also the statistics starts in some cases of economics. So if you ask directly what is statistics so far as research methodology is concerned, what is statistics? So for as research methodology is concerned, if I'll ask this specific question, what is statistics for research methodology? That means to carry out the research, especially the social science research. The management research is mostly the social science research. What we can say, socio-economic research or socio-psychological research. I say most of the time management research is socio-economic research or socio-psychological research. The moment we apply the statistics in socio-economic research or socio-psychological research, what is statistics? My question is, in this case, the answer will be the opinion of a great statistician. I'm sorry, the person is not a statistician, but the foundation comes from this person's opinion or dialogue. Can you imagine who is that person? We all familiar to that person. Look at this person. I'm sorry, he is not a statistician. I'm sorry, he is not a statistician, but the foundation of statistics to be applied, the foundation of statistics to be applied can be obtained from this person's dialogue. कितना आदमी थे और तुम कितने थे, कितना गोली है, so it is saying 6, then 3 bullets it is firing in the air, it is saying now 3 आदमी 3 गोली बराबर. Try to understand, the moment we are equating the frequency with the target, we are equating something that you need to achieve in the future. From there the application of statistics starts. My dear friends, I am not talking about statistics, I am saying about application of statistics. I am talking about application of statistics. The moment we are familiarizing the concept to be applied in the future course of action, we are equating the frequency that is to be applied in the future context. From there the application of statistics starts. So in the sense we can say it is a research methodology. So most of the time from very beginning there is a wrong conception in the initial stage of MBA or MPhil. Research methodology is nothing but statistics. This wrong conception is building so many wrong things later on. So let us not to be having the wrong conception. So as our module refers, so today's session deals with the 2 eminent theory. One is classical test theory, and over the time period the classical test theory has been replaced by, I cannot say replaced by, the classical test theory has been preceded over the latent variable theory or latent variable model. And mostly the classical test theory, it has been started in 1904, and in 1966 2 eminent researchers, they have started saying that the total score of a test, try to focus. Yes, is there anybody asking something? I'm sorry, is there anybody asking something? Dr. Barada, any problem?
No, sir. Please continue.
Okay. So the classical
Please
test theory is saying that the total score of a test, try to emphasize on my term test, not on the item, not on the question, not on the variable. The total score of a test is counted for latent context, not every item. That means the observed score after administering a data collection instrument, the score the researcher is obtaining is equal to the true score plus error. What I am saying, give me 1 minute, please. Give me 1 second. Huh. So the total score, suppose I will say I am observing the score of X. The total score is equal to the true score plus error. The true score plus error. Some variables you are measuring, x1, x2, x3. Likewise, some variables you are measuring. Some variables you are measuring. Suppose these three variables you are measuring. The total score is X of these three variables, and the total score is equal to the true score, the true total score of all these three variables plus the error. So what is the meaning? The moment we are observing, researcher is observing the observed score has some scope to be evaluated along with error. Now, when the error comes, the error comes when you are measuring with some instrument. So it is a measurement error. So it is the measurement error. Try to remember the errors: random error, measurement error, systematic error. So it is the measurement error. While you are measuring some variables, I repeat, while you are measuring some variables, the measurement itself, the technique itself has some error. And the error score, whenever it is added with the true score, that becomes the observed score. That means there is no scope available to know individually this variable score. Individually this variable score. Try to understand. Individually this variable score, there is no scope to know. What I'm trying to say here is, individually these scores are not available. That means there is no scope to evaluate how these three variables are related to each other in order to form a latent variable. I repeat, there is no scope to know how these three variables are related to each other in order to know the latent variable, which is the fundamental of today's structural equation modeling. So that is the reason there are so many lacuna, there are so many loopholes. There are so many loopholes from this classical test theory. Reliable. Try to understand. The test score are reliable. What is that reliability? Reliability is nothing but how much the observed score is performing in comparison to the true score. How much the observed score is performing in comparison to the true score. How we are measuring the score in case of our statistics variance. Now px square, if it is the total score, then sigma t square plus e. Now in order to know the reliability, what we will know, how much this much is derived from this true score. That means reliability is equal to the px square with ratio of sigma t square variance. I hope you are clear till now. Now please understand, if you want to know how much this true score represents, now make it reverse. Reliability or variance of true score, let us say variance of true score divided by the probability that, till now the probability word has not come because I am using the word P. I am saying the observed score is equal to reliability. That means instead of this, what I can write now? I can write now sigma square t divided by sigma square t plus e. I hope you are clear, all of you. I hope you are clear. I have written in the denominator this. I hope all of you are clear. If anybody is having any doubt, that means the classical test theory says the test score have an interval measurement level. We cannot say it is in a continuous data, which lack of theoretical and empirical basis. The moment variable x, variable y, variable z is constructing the factor A, variable p, variable q, variable c is constructing the factor B. The moment we are saying this much of thing, there is no scope to test it through the classical test theory. I repeat, suppose I am saying x1, x2, x3 is constructing A, x4, x5, x6 and x7 is constructing the factor B, x8, x9, x12, x13 is constructing the factor D. There is no scope how to test because we are taking the total score. So there is no empirical evidence, there is no empirical basis or theoretical basis here. And this is the main drawback. This is the main drawback of a classical test theory, for which the researcher has landed on the latent variable model or latent variable theory. I am clear till now? I am clear till now? I hope I am clear till now. I hope I am clear till now.
Yes, sir.
See,
Yes.
at
Yes,
some
sir.
point of time, somebody should say yes or something like. Otherwise, I am thinking that I am going unilaterally. So what is happening? Because of this drawback, again I am saying, what is another drawback? Another drawback is the classical test theory depends upon the test itself. That means it assumes the person or the researcher who is testing has every ability to test the attributes of measurement. Suppose you are measuring attitude. Suppose you are measuring perception. The researcher has every ability to test the attitude of the respondents. The researcher has every ability to take the individuals who can measure the perception for my research, which is not the case in every researcher's case. We cannot assume anybody who will perform my research has the same ability to measure the attitude on my context. I cannot assume at all. So the classical test theory is test specific. The moment it is test specific, it is assuming the researcher has every ability to test. That means the moment ability of the researchers vary, the reliability vary, which cannot be presumed in research. The moment ability of the researcher vary, reliability of the instrument vary, or reliability of the items of the questionnaire varies, then it is creating an enormous disturbance. It is creating a very much disturbance. I hope you are clear all. I hope you are all clear. That is the reason the researcher think, instead of the total score of x1, x2, x3, which is building the construct A, let us try to know what is the latent attribute, latent characteristics that x1, x2 and x3 is sharing with each other. Latent attribute. Please try to understand what is the latent attribute or latent characteristics that the x1, x2, x3 are sharing with each other. That is the reason x1, x2 and x3 researcher has put on the A. That means the construct A or the factor A is built up of x1, x2, x3. It is because x1, x2, x3 are sharing some properties or characteristics. Later on, we will discuss that these are all called as psychometric properties. x1, x2, and x3 are sharing some psychometric properties in common. In common. That is the reason x1, x2, x3 I am bringing together under an umbrella, and the umbrella is a factor for me. So this sense was absent in case of classical test theory. Now we landed on the latent variable model or latent variable theory. That means instead of taking the total score of x1, x2, x3, let us take the score of every x1, x2, x3 isolatedly and try to know what is the variance they are explaining in common. So that is the reason people started saying the modern theories or modern models as the item response theory. The item response theory is nothing but a family of mathematical models. Item response theory is nothing but a family of mathematical models which represent a common variance among various items that has been considered under a particular construct or variable, under a particular construct or factor. So one of the popular name of the item response theory is called as latent variable model or latent variable theory. And the latent variable model, which is a popular name of item response theory, IRT, now has been extended to a popular model that we were discussing very much enormously. Somebody has used the SCM in the thesis, means a great thing. Actually, it is not that much a great thing. Simple, some common variance, some variables are sharing with each other. That has to be identified by the researcher and bringing together a single or common umbrella. And that umbrella is nothing but a common variable or a common name or a common construct. Likewise, x4, x5, x6, x8 are coming under another umbrella. So the item response theory is giving an advantage over classical test theory. The item response theory is giving an advantage of classical test theory in such a manner that the latent characteristics or properties of every items are taken into consideration. For every items, there is a scope to build the model. Model means mathematical or statistical model. There is a scope for every item to put in the model, not the total score as it was happening in the classical test theory. However, the classical test theory has given a sunlight to every researchers that whatever measurement we the researcher are doing, the score may be variance, maybe standard deviation, maybe standard error, whatever you say, in common we are saying variance. Whatever score in the measurement we are doing, that is not final, rather the measurement specific error is there. This common property has enlarged or is becoming the eye opener for every researcher later on. So this common theme has been taken into the latent variable theory also, which is popularly known as item response theory. That some score is there that has been observed by the researcher, and that score is not fully explaining the property of the construct, hence some error need to be added. I repeat, the score that has been observed means by estimation method. The score that has been observed by the estimation method is not sufficient to explain the characteristics of the latent variable or the construct or the factor. That means something else has been left out. What is that? That is error. This particular common phenomenon of the classical test theory has been taken in the latent variable model also, and popularly which is known as item response theory, IRT. But here the major aspect is the latent property is commonly shared among the items. Latent construct is commonly shared among the items. Another drawback will clarify your doubt more. What is happening in the classical test theory? Classical test theory assumes that whatever test you adopt, that test you give you similar result or same result unless and until your test is not altered. If test method is altered, I am repeatedly saying it is basing upon the test method itself. Unless and until your test method is not altered, is not changed, it will go on giving the similar result or same result. That means the error is nothing but the standard error. The error is nothing but the standard error. In general, in the statistics, whatever we are discussing the standard error, that sigma x bar is equal to sigma by root over of n. That means variability among the samples. Variability among the samples. That means the classical test theory is equalizing the measurement error into standard error, which is completely a wrong thing. That means the moment you are taking the score in total, this phenomenon will occur. The measurement error will be equalized or will be assumed to be equal with the standard error, but which is wrong thing. Why? The moment you are altering the items, the error changes. The moment you are altering the ground of testing, that means perception of business person, the same item you are measuring the perception of government servant. Can we say the measurement error will be similar or same? Never. But in the classical test theory is saying, no. The same three items you have taken to measure the perception of business person, if you are taking to measure the perception of a government servant, then it will give you the same result. That means it has equalized with the standard error, which is not the case. How it will be changed? Now the three items you have taken to measure the perception of a business person, if these three items are sharing some psychometric property in common, and based upon that you are saying a particular construct. Suppose selective attention, selective distortion, these are all two stages of perception we all know, come across in the OB or in the HR. Suppose three items you have measured to know the selective attention, another four items you have taken to measure selective distortion. Suppose one construct name is selective attention, under that three items are there. Another construct name is selective distortion, under whom there are five items. You are measuring the perception of a business person. Now the same 3 and 4 or 7 items you are taken to measure the perception of government servant, purely the government servant, then the measurement error will differ. But the classical test theory is saying it is not differing because it is equal to the standard error. If your sample is correct, then everything is correct. Classical test theory is saying. So this is the reason the latent variable is taking advantage over classical test theory. No. Even if the same items you are taking, measuring the same property, that is perception, if the respondents vary, if the items vary, then the measurement error will vary also. Try to understand. Now, our difference will make it clarification to some other extents. Can anybody say something, or anybody want to share something or any doubt? Because till now, I hope there is no response. There is nothing, no two-way communication. So I am in doubt whether my thought is reaching to you or not.
We are, excuse me, sir. We are listening only, sir. Because in between, I think we have nothing to ask, sir.
Still
whenever
I'm saying,
yeah, sir. Whenever we get the practical things, then obviously we will ask, sir.
Okay. So these are all not the direct practicable aspect. These are all the fundamental to go to the SEM, structural equation modeling. To go to the structural equation modeling, these are all the fundamental things. And hats up to ASBM University, they have put this particular topic at the beginning of this SEM class. Because directly jumping into the structural equation modeling most of the time, making the people simply some expert. I hope you have read an article in the social media, one eminent professor of Oxford University or Cambridge University given the advice to the guide that do not try to make your scholar the expert only. Try to make the scholar as the thinker. Most of the time we know how to operate the software, we got the result, we interpreted the result, matter is over. But how the structural equation modeling has been developed over the time period, if anybody do not know the application part, he or she will fumble, or the application part, he or she will not be appropriate. And this is the problem nowadays to most of the researchers, most of the scholars. And they are thinking anyhow, put some statistics, matter is over, thesis is over, article is over. But know where to apply, why to apply, or why not to apply. And these are all the fundamental. The item response theory and classical test theory. Okay. Rightly I said, the classical test theory is based upon the test. Test is the unit of analysis. But in the item response theory, and that's because it is a family of mathematical model, the items are the unit of analysis. Simply I am saying a multiple linear regression. What is that? Multiple linear regression. What is that? The regression value is equal to a plus b1 x1 plus b2 x2 plus b3 x3 up to bn xn. This is the multiple linear regression. The moment there are 4 variables, we are taking b1 x1, b2 x2, b3 x3, b4 x4. The moment it is 5 items, we will go up to the 5 variables. The moment it is 10 items, we will go up to the x10 and b10. What is happening? The classical test theory is saying now the total score will remain constant. If the test is same, the total score will remain constant. That means if the test is same, error will not change. Simply they are saying error will not change. But item response theory is saying every item must be considered. And every item coming under one umbrella because they are sharing some common psychometric property. They are sharing some common psychometric property, and hence the researcher has bringing together all these 3 or 4 or 5 items under a particular construct or factor or latent variable, whatever you say. So the items are the units of analysis. Try to understand. So in one way, the classical test theory is measuring with more items. That means more the items, more will be the reliability. Try to understand what I'm saying. I'm coming to the same example. Suppose I'm saying measuring the perception of business person by 3 items. They are bargaining power, 1 item, and their patience to show their talent to the customer, another item, and their ability to explain the products. By these 3 items, you are measuring the perception of business person on the ground of today's pandemic situation. Suppose I will add another item. His or her experience in the same business. I will add 5th item. His or her family experience or family bonding in the same business or family support in the same business. The more you go on adding the items, the perception score will be more. In the classical test theory, the perception score will be more. Try to understand. But reverse is the case in case of item response theory. Measures with the lesser item and can be more reliable because the stronger the property they share with each other, more will be the reliability. How the property will be shared in common? If there will be lesser number of members in the team, very simple common phenomenon of our society. Less number of people in the team, they will share a strong bonding, and which is reflected as the reliability. More is the sharing or stronger will be the sharing of common phenomenon or common psychometric property, more will be the reliability in case of item response theory. And this is the reason the item response theory is taking advantage over the classical test theory. And this is the reason the psychometric property in common they are describing is the foundation of today's structural equation modeling, which is popularly we are saying latent test theory. So comparing the score from different measures can only be done when the test forms or measures are parallel. Try to understand what is happening here. Item response of different measures can be compared as long as they are measuring the same latent trait. Latent trait I am saying, that means the common phenomenon they are sharing, that is latent trait. The common phenomenon they are sharing, as long as the same common phenomenon exists or persists, the item responses of different measures can be compared. Item property depend upon representative sample, but item property do not depend upon representative of sample. Why? The researcher's ability vary of selecting the sample element, we know, but in the classical test theory that is assumed to be same, assumed to be similar. Ki the item we are taking, I am taking, will be definitely same Mr. X is taking, will be definitely same the Mr. Y is taking. It is assumed to be true. Assumed to be similar. And here the measurement error originates, which has not been ignored by IRT, item response theory. If the sample element drawing, from here the probability statistics starts. The probability by which any element of the population is selected for the sample do carry some error. Hence, item property do not depend upon representative sample, rather depend upon the probability of selecting the sample element. Sample as a whole is not depending. Try to understand. So, in common, the property they are sharing is becoming the score reflection. The common property they are sharing is reflecting the score in case of item response theory. And this is the foundation of the structural equation modeling. I hope till now clear. I should not go to any deep of these two theories. I should go to the structural equation modeling. I hope till now, if any doubt, you can say it. You can come forward. Because I'm thinking most of you becoming the passive listener most of the time. I do not know, because these are the foundation theory for the structural equation modeling. I'm in a doubt of the audience response. Any doubt, Dr. Barada? Any doubt, or should I move ahead?
Everybody is listening, sir, and all are actively participating in all the sessions.
Okay. Yes, sir. And we
if
don't
no
want
question,
to
they understood.
disturb your flow, sir.
No
Okay, okay.
Yeah,
so my voice is
we
clear.
don't want to
My
disturb
voice is
in between.
okay.
Yes, sir.
My voice is clear to all.
Yes, sir.
Yes, it's clear. Yes, sir.
Okay, okay. So now we will jump into structural equation modeling. See, later on I will say, in general, we are analyzing the SEM, structural equation modeling, in two ways in the academic research. One is a covariance based, one is least square method. And all my classes right now will be based upon covariance based. So I have chosen all the explanation based upon the covariance based. Although I will say some difference between these two later on, but all my discussion from today onwards will be based upon covariance based structural equation modeling, which is mostly done in the Amos software. So as because our workshop software is Amos, I have chosen the covariance based structural equation modeling. So what is SCM? Let us start our discussion. Let us continue our discussion from the item response theory. Some phenomenon the items are sharing in common. X1, X2, X3 are coming under the latent variable A. Latent variable we can say, construct we can say, factor we can say. So these are all the X1, X2, X3, they are sharing in common and hence forming A. X4, X5, X6, X7, they are sharing some common psychometric property and
Excuse
hence,
me, sir.
yes.
Sir, can you please explain with an example where the IRT and CTT is being used?
Is
Being used. Where we can use means for, with an example or something.
I am saying now the use of item response theory.
Okay, okay.
I am saying now the use of item response theory. Item response theory has been used extensively in the today's modern statistical technique. One of the modern statistical technique is SCM. Structural equation modeling means simultaneously some equation will be solved, and which the item response theory is saying a family of mathematical models. Getting my point, madam?
Sir,
Getting
I
my point?
am talking about an example, like with some example with variables
The
or
moment,
sample.
the moment we will use the SCM, you will know one SCM structure I will build by taking one of the data file. I will share you data file next class onwards. Exactly what you mean to ask, I do not find. Use means wherever you are using the structural equation modeling, that is a use of IRT. Wherever you are using structural equation modeling, that is a use of IRT. Very simple. Earlier, the
Sir,
use of
excuse me, sir.
Yes.
Yeah. I think she wants to know classical test theory. That means likewise your T test, Z test, or chi-square test, or ANOVA. These are called classical test theory.
No,
So
no, 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 not
wherever
exactly.
you are to apply, then
Okay,
sir.
okay, continue. Carry on.
Yeah.
Carry on.
Yeah, sir. Yeah, that part will be from my point. That part will be classical test theory, and whenever you are going to apply this, suppose you want to know the consumer behaviors and perceptions, etc., then generally people want to use this chi-square test. So that is also one kind of classical test theory. But whenever you are going to item response theory, then for every item, what is the impact, what is the loading, that will be discussed. I think. Am I clear, sir?
Yes. To some extent, the latter part of your explanation is okay. The moment you are saying chi-square, where, see, try to understand, madam, where the items for a factor is not sharing a common phenomenon, and the total score you are considering as a whole, that is the application of item, that is the application of classical test theory. Rightly, sir is saying the chi-square test. But the moment we are saying some variables are coming under a single factor, nowadays the application of SEM, that is the application of item response theory. That means some common phenomenon, yani ki the latent trait, personality trait, you must be knowing latent trait, and a latent trait or some common latent trait persist or exist within these variables, those who are forming one construct. Anywhere you are taking, suppose you are measuring attitude of employee. Attitude of employee, suppose you are saying proactive and reactive. Proactive is one construct and reactive is another construct. Suppose you are measuring attitude in the tri-component model. There is a tri-component model, cognitive, cognitive, and affective. And the cognitive component having 4 variables, yani ki 4 items in the questionnaire. Cognitive construct carrying 7 items in your questionnaire. Affective component carrying 10 items in your questionnaire. These 4, 7, and 10 items you have taken separately because the 4 items are sharing some common phenomenon to form cognition. Second set of 7 variable, that means 7 items in your questionnaire, you are putting to the respondent. They are sharing some common phenomenon to form affective component, and cognitive component 10 items you are asking in the questionnaire. The moment you are saying some common phenomenon exists between the items, and based upon the common phenomenon you are measuring the items, you are measuring the attitude. In my example, that is the application of item response theory, where the common phenomenon is not presumed, and that is the application of classical test theory. What earlier was happening, the total score, okay, these 4 variables we are taking, what is the total score? That is the value of attitude. So we are not saying the common, earlier how the attitude was measured. Earlier attitude was measured in the traditional case directly 10 or 12 questions. What is the total score? That is the value. That total score means variance. Simply, that is the score of the variance. The total variance is the score of the attitude. But is it true? Suppose you are measuring the attitude of business person by 10 items. The total score you are saying high. The same 10 items you are administering to the completely to the government employees. Will they give you the same score? But the classical test theory is saying that they will give the same score. But the item response theory is saying no. What is the guarantee that they will give the same score unless and until you know what is the common property they are sharing with each other? In the traditional case,
Right.
the total. Got my point, madam?
Yes, yes, sir, yes.
So the moment the SCM application you will know, you will more clarified. I can understand. I can understand your point. The moment you will know the SCM application, you can know, madam. Madam, any doubt?
Yes, sir. No, sir. You continue, sir.
No, no. Till now, my answer is satisfactory, or still some doubt is there?
मुझे नहीं पता ऑली देख ले उठ के यार थोड़ा उठ जाया कर
Some
ये बर्तन
disturbance is
लेके
there.
जा
May I request somebody to mute the audio? Okay. So, okay. Should I move on? Should I move
Yes,
on?
sir. It's understandable till now.
Okay.
Thank you.
So, the structural equation modeling is saying it is a, as I said, two type of structural equation modeling in our academic research we will come across. So, and one is covariance based, one is least partial least square based. I am focusing on covariance based because our software is Amos. So what is SCM is saying? It is a covariance structural analysis. Why the word structural later on will be clarified. Do not worry. Is a covariance based structural analysis which tests the causal relationship. Try to understand, madam. Your doubt will be clarified here also. Where there is a causal relationship, that means not only the items among them are sharing a common property, but also every item is causing a latent variable. Simultaneously, if three items are there under a single construct, three equations will be solved simultaneously. And if the construct A is leading to construct B and construct B is made up of 7 items, then simultaneously these 3 items and those 7 items will be solved. Later on, the word structure will be clear. Do not worry. So SCM enables the researchers to incorporate unobserved variables also. What is that unobserved variables? The indicators, or we can say exogenous variable initially, let us say, that means that you are measuring, that the researcher is measuring. The exogenous variables or the indicators, most of the popular term we are using indicators. The exogenous variables or the indicators are very fundamental, we can say independent variables that we are directly measuring cannot measure fully the latent construct. Some errors are there. And these errors can be measured in structural equation modeling, but was very little scope to be measured in the classical test theory. How you will be knowing very well, do not worry. While I will perform the Amos software, you will be knowing, do not worry. So SCM allows modeling and testing of relationship. That means 4 items under construct A, 7 items under construct B, 10 items under construct C, yani ki model A, model B, model C you have built, and relationship between model A, model B and model C also tested. So model is tested, relationship is tested simultaneously in the SEM. Model is tested, relationship is tested. Later on, the word model I am using, later on it will be used as a measurement model, which tested through CFA, conformatory factor analysis. I repeat, 4 items are measuring the construct A, 7 items are measuring construct B. Suppose I'm giving a hypothetical example. 10 items are measuring construct C. So structural equation modeling is simultaneously testing based upon the theory, based upon the concept, based upon the literature. The researcher has taken 4 items. Is it true now? Based upon the literature, the researcher has taken 7 items under a construct B. Is it really hold good? 10 items the researcher has taken based upon the literature under the construct C. Is it holding good till now also? That means the model are tested. Later on, this model will be called as measurement model. Please remember. And the measurement model will be tested by CFA, confirmatory factor analysis. Not only the measurement model are tested, but also what is the relationship between A, B, and C, A to B or B to A leads to B or B leads to A, or C leads to B or A leads to C. All these relationships are also tested simultaneously. So that is the reason most of the time we say the structural equation modeling is nothing but a overall summation of factor analysis and regression. Most of the time, not exactly it is true, but for a common layman point of view, we say structural equation modeling is nothing but a summation of or a combined estimation of the factor analysis and regression. The moment structural equation modeling was not there, what were happening? Please remember, we are measuring aptitude by 20 items. We are administering factor analysis. After administering factor analysis, we are getting 5 factors. And these 5 factors we are putting as independent variable for the regression, multiple regression. Suppose we are saying, what is the relationship between aptitude and satisfaction? In order to measure the aptitude, we are taking 20 items in the questionnaire. In order to measure the satisfaction, we are taking 2 to 3 items in the questionnaire. Now we are entering 20 items of the questionnaire into the factor analysis. We got 5 to 6 factor. Now this 5 to 6 factor become independent variable for further multivariate analysis. In our example, further multivariate analysis is multiple regression, multiple linear regression. Now these 5 to 6 factor become independent variable for the multiple linear regression. So these 5 to 6 variables are independent and satisfaction is the dependent, and we are carrying separately, we are administering separately the multiple linear regression. But both of the phenomenon will simultaneously happen in the structural equation modeling, because psychometric property cannot be isolated most of the time. Try to understand. So that is the reason SCM technique are known as second generation of data analysis nowadays. See, initially what was happening in the traditional case, I was saying, I was separately administering factor analysis. Whatever factors are obtained, I am putting into further multivariate analysis. But right now, it is happening simultaneously. It's the second generation of data analysis. Now, third generation has been adopted by the artificial intelligence, by machine learning. So, the structural equation modeling is saying that simultaneously model is tested, relationship is tested, the strength of the relationship is tested. Relationship and strength of the relationship are nothing but your hypothesis. There is a significant relationship between attitude and satisfaction. You are taking the hypothesis, and this thing will be tested by the relationship between construct A to construct B. I hope you are clear, all of you, till now. I hope all of you are clear till now.
Yes,
Anybody
sir.
having
Yes,
any
sir.
question?
Yes, sir. Thank you.
Excuse me, sir.
As I said, SCM are of 2 types: covariance based and partial least square based. And this partial least square based covariance, partial least square based technique is mostly adopted by a particular software called as Smart PLS. So I am not our present workshop is most upon based upon the Amos. There is a software called as Smart PLS, and some other software are there, and this is the popular software. And we are using this covariance based SCM, and this covariance based SCM is having some advantage over least square based method. Why? The covariance based method is strictly assuming the error, which is in reality happening. But the error assumption in case of partial least square is ignored. Mostly the error assumption is ignored here. And so many other differences are there. As I go on administering the SCM in Amos, you will be knowing. Do not worry. What is that covariance based? See, what is the covariance fundamentally? How simultaneously the variable x1, variable x2, variable x3 are varying simultaneously. That means the variance they are sharing with each other under a common platform, and that is the reason these three variables we are putting under a particular construct. That means the variance, the moment they are vary along with or with respect to other variable, and the covariance is 0, that means the relationship between these two variables are null or nil. Simply we can say the covariance is nothing but standardized correlation. You must be knowing correlation, R square and adjusted R square. If you take standardized R square or standardized adjusted R square, then this is nothing but the covariance. Simply we can say variable x1 is varying with respect to variable x2, also varying with respect to variable x3. The rate at which, the rhythm at which, the step at which, by which, the speed by which, the matter by which variable x will vary, yani variance is changing in the same manner, in the same rate, in the same way x2 is varying. If not, covariance is less. In the same manner, x3 is varying. If not, covariance is less. So most of the time we say the covariance in case of structural equation modeling is nothing but a correlation, a standardized form of correlation. So one intelligence we are getting now, the input value for the structural equation modeling is the correlation table or covariance table. I will say how later on, do not worry. The input for the structural equation modeling is the correlation among the items. Try to understand. Okay, let me say here. Suppose there are 4 or 5 items: x1, x2, x3. Suppose x3, x4, and x5. Suppose there are 5 items, and these 5 items, out of these 5 items, these 3 items are under 1. Suppose 6 items, x6, and these 3 items under another construct, suppose f, and it is p, suppose. Now the input matrix or the input values are the correlation matrix. What is the correlation? Suppose here I will take x1. Please look at here, please have the attention. x2, x3, x4, x5, and x6. So the diagonal values of this matrix are always 1, because relation of x1 with x1 is 1. So all the off diagonal values, x2 with x1 is here, value is here, x3 is x1 is here, x3 with the x2 will be here. Try to please focus on the screen. And x4 with the x1 is here, x4 with the x2 is here, x4 with the x3 is here, likewise. And this correlation matrix we are saying as a covariance, if we are taking in the standardized form, become the input for structural equation modeling. The moment the input matrix will be equalized by output matrix, that means what is the relationship between x1, x2, x3? Simply x1, look at here, please, all of you focus, x2, x3. After analysis, another matrix is created. The analysis will give you, the software will give you, earlier manually it was given x1, x2, x3. So that will be relationship now. Look at here. How much similarity are there, this output matrix with this input matrix? That much is the model fit. I hope all of you are clear. Any doubt till now?
Yes, sir.
Any doubt till now? So the structural equation modeling in case of PLS SCM is informative in nature. That is a separate session, formative versus your reflective. I hope in my 4th class it is there. Do not worry. Simply now you say the PLS based SCM is formative in nature, and right now whatever you are discussing, that is reflective in nature. So covariance based SCM is reflective in nature mostly, and hence adopted or administered by Amos. So Amos will perform mostly the reflective measurement, not the formative measurement. Whereas PLS SCM will say formative measurement, and in some cases reflective measurement also. But the irony is, in case of PLS SCM, the error measurement is not taken that much of seriously, or error measurement is not considered at all in most of the cases. So that is the reason the reflective measurement Amos is taking advantage over PLS SCM. Still, people are doing the research on PLS SCM, not an issue. I am not saying that something is weaker, something is greater, something is acceptable, something is not acceptable. The research where error term is very much strict, and most of the article reviewer are looking for the error term. So they are mostly looking at the Amos output. That means the reflective SCM rather than formative SCM. Still, some of the articles are accepted by the formative SCM. There is no such hard and fast rule. It is because reflective SCM is considering error term more seriously. It is because reflective SCM, that means covariance based SCM, is considering the error term while measuring the items, and it is supposed to be the more reliable over the time period. So that is the reason most of the researchers in famous journal, they are prefer to adopt the Amos for the structural equation modeling. And here our focus is Amos. And there are some other software, Lisnel, EQS, so many other softwares are there. So many other softwares are there. So I have just listed some of the softwares. I hope till now some fundamental of SCM is clear. Should I proceed or any doubt? Should I proceed or any doubt? Should I proceed, Dr. Baroda?
Yes, please. Yes, please.
Should I proceed?
Yes, please.
Yes,
Okay.
sir.
In the correlation,
Madam, so you are asking something. Tell me.
sir, in the correlation matrix, sir, like you have written in the diagonal 1, 1, 1. So that is okay. That it shows the relationship of x1 with x1 will be 1, of x2 with x2 will be 1. But apart from that, sir, in the other sides you have written 0, 0 only. So why only zeros?
No, 0. I have shown it as some value.
Okay,
not
sir.
0.
Okay, sir. Okay. So that's why I was quite confused, because at later stage you said the extent to which this input diagonal, the input matrix will be identical with the output matrix will be determining the R square value. So that's why I was quite confused. Okay, sir.
No. You are true to some extent, but you are saying R square, not R square. I am saying, please try to understand. I am saying later on it will be clear. Do not worry. The moment I will operate, it will be clear. Do not worry. I am saying the moment you are testing the model fit, you are testing the model fit, at that time we are saying that model is fit whose output correlation matrix is very much similar to or closer to input correlation matrix.
Okay, sir.
Here the correlation is nothing but covariance. Madam, am I clear?
Yes, sir. Yes, sir. Please. Thank you. Thank you so much.
Likewise, I'm expecting some clarification from the audience. Otherwise, I'm thinking I'm only go on speaking like a political speaker.
Anyway. We are all listening to you, sir. Actually, we are listening very carefully. That's why we are not interrupting, sir.
Okay. Do not worry. But the moment I'm switching some slide, in that time you can ask. Do not worry.
Okay, sir. Thank you.
Okay. So some terms, because time is very limited. I'm not going to in detail. Some terms that will clarify the SCM. See, The moment you will go through any book, any article of fundamental of SCM, you will know the role of theory. Why? See, repeatedly I'm saying the items you have derived from theory or concept or literature, the construct you build by taking item based upon literature. Everyone saying literature, literature, literature. Why? So that is the reason popularly we are saying SEM is mostly or commonly known as a confirmatory technique. Is a confirmatory technique. Is a confirmatory technique. You are confirming some theory. You are confirming some model. You are confirming some concept. How you are confirming? By empirical result. By empirical result. Hence you are testing the model. Hence you are testing the hypothesis by taking the relationship between various construct. So the fundamental ground to proceed with the SCM is the theory. Theory does not mean only 2-3 lines. Theory means any model, any concept, any pictorial diagram, any logical relationship, any existing statistical equation. So there is a great role of theory in SCM. So that is the reason we guides are saying to our scholar कि literature review must be very much extensive, very extensive. For every construct, for every items, there must be a substantial evidence of theory. Then only we can justify your application of SCM is correct. Only to make a thesis, apply the SCM, and everybody will say, wow, it is not correct at all. Unless and until the scholar is substantiating the model by literature. So that is a role of theory. Next, why the theory is so important? The theory will say you why or on which ground the common psychometric property. Is there anybody saying something? Is there anybody saying something? Okay.
I think they are reading. I think they are reading, sir. Reading this this PPT, sir.
Okay, please, anybody please mute so that if you are having any question, you can ask, otherwise mute. Okay. So the theory, second aspect of theory, what is the role of theory? That is most important to understand for structural equation modeling. Theory will show you what is the common psychometric phenomenon based upon which you have taken x1, x2, x3 under A. You have taken x4, x5, x6 under construct B. What is the common phenomenon x1, x2, x3 are sharing with each other? The theory will say you. Suppose extension of Maslow's need hierarchy is Hochberg's two-factor theory. Hochberg is saying that all the upper level needs are the really motivator, our lower level needs are the hygienic factors. So two constructs you are getting, motivators, hygienic factors. Now you got the common phenomenon. Why basic need or physiological need and safety need must come under one construct. Try to understand. In the Maslow's need hierarchy, there is a physiological need. Then upper need is safety need. And we are taking two variables, two items for the physiological needs, suppose 4 items for the safety needs, suppose 6 items we are taking under one construct, that is hygienic factor. One construct, that is hygienic factor. Now I am ready to say why I have taken these 6 factors under a construct. That is a substantial theory. There is a substantial theory. Theory is substantiating that a common phenomenon, hygienic phenomenon, they are sharing. These 2 plus 4, 6. These 6 items are sharing the common phenomenon among themselves. That is the reason. What is the common phenomenon? Hygienic phenomenon. That is the reason these 6 items I have taken under the hygienic factor. Factor name is hygienic factor, or construct name is hygienic factor, or latent variable name is hygienic factor. Latent variable or construct or factor, you have to say. I hope I am clear. So there is a great role of theory in structural equation modeling. As usual, model is a set of interdependent relationship, nothing to say. I have already said covariance. Between 2 or 3 variables, they are coming under a single relationship or under a complete a single variable or a factor. They are variable simultaneously with respect to each other. They vary simultaneously with respect to each other. Statistically, we are calculating by variance. Variance of x1 is varying. Variance of x1 is accelerating or decelerating with respect to x2. Variance of x2 is accelerating or decelerating with x3. Variance of x3 is accelerating or decelerating with x2 and x1. If this is the case, then that is covariance. That means if the covariance is 0, variance of x1 may be high, but it is not accelerating or decelerating with respect to x2 and x3 if the covariance is 0. If the covariance is 0, variance of x1 may be much more high than x2 and x3, but it is not varying with respect to x2 and x3. If it is varying with x2 and x3, the covariance will never be 0. Covariance will be high. Very simple. So that is the reason we are saying it is a correlation, standardized correlation. Covariance is nothing but a standardized correlation. Very simple. So this is the fundamental of ACM. Now, exogenous and endogenous variable. Endogenous variable is caused by 1 or 2 more variables, and especially I am taking some of the term from David Kenny and other term from the book Hare Anderson Tatham. I am saying 2 things. There is a very famous book of multivariate analysis, author Hare Anderson Black Tatham. Some of the term I have taken from that book, and some of the term the famous research methodology statistician nowadays for the ACM, David Kenny. I am taken some term from David Kenny, and second term, some term from the Klein, K-L-I-N. So do not worry, all these things are existing in the books or websites. Do not worry. I have simply organized in a systematic way to introduce you people to the ACM. I believe those who have already known regarding ACM, they might be getting bored, I believe. But do not worry, the moment I will practice in the Amos platform, you will be familiar. Those people who have already introduced with ACM, they will be getting bored with this. But I have to say, because some beginners are there, I believe. Any people, any participant who is getting bored with this, because if anybody has been familiar with ACM, they will get bored. Anybody? Should I directly jump into the Amos practice? Should I directly jump into Dr. Baroda?
No, sir.
Okay. So endogenous variables, especially these.
I have a query, and that is
yes.
regarding the substantial theory. Can you throw some more light on substantial theory you were just speaking?
Theory must substantiate your model. Theory must substantiate your model. Unless and until there is a sufficient background available in the literature for your model to be tested in the ACM, we cannot say ACM is applicable to your research. One example I have said now, suppose you are measuring the motivating factors. Suppose. So Maslow's need hierarchy theory is saying physiological need, safety need, social need, esteem need, self-actualization need. But I am measuring under 2 construct. Now you will ask me, sir, why you have taken 2 construct? I will say Hochberg 2-factor theory is substantiating my assumption that all the factors can come under 2-factor, 2 latent variable. For the research methodology for this ACM, it will become the latent variable. So for the physiological need, I will take some items in the questionnaire. For the safety needs, I will take some items in the questionnaire. Suppose these are all 7 to 8 items. These 7 to 8 items I will put under 1 construct. Do not worry. The moment I will show you in the Amos graphic, you will be clear. The moment these 7 to 8 items I will put under 1 construct or factor. Now you will ask question, sir, on which basis you are taking these 7 items under 1 construct? I will say that is a substantial theory. What is that theory? Hochberg 2-factor theory is saying both the basic need or physiological need and safety need can come under 1 factor, that is hygienic factor. Am I clear, sir?
Right, sir. Thank you.
That means any model you are testing, your literature support must be there. Directly I can say, any model you are testing on ACM, sufficient literature support must be there. Otherwise, application of ACM is in question mark. Am I clear, sir? Okay. So the exogenous variables are not caused by other variables. Rather, they are causing one or more variables. So that is the reason the exogenous variables we are saying later on indicators which are measured, and the endogenous variables are called as later on latent variable or factor. Now confirmatory analysis, I have said pre-specified model you are testing. Now the moment you are testing, look at here, this is one construct and these are all three variables. Suppose these are all three variables. Suppose these are all three variables, and these three variables, how much they are internally consistent. How much they are internally consistent, that is the reason the researcher have taken these three variables under one construct, will be tested by Cronbach alpha here also, because Cronbach alpha is saying the internal consistency mostly. But this is not the only measurement to say the reliability for the ACM. Some other measurement is there, like composite reliability, CR. I will say later on, do not worry. One of the very basic way of measuring the reliability, why you have taken how much strong relationship exists between these three variables, so that you have taken under one construct, one answer will be given by Cronbach alpha, because Cronbach alpha is saying internal consistency, because Cronbach alpha is testing the internal consistency. I hope I am clear now till now. Now, the moment I said, please remember, the input correlation matrix is similar to how much the output correlation matrix. How it will be known? How it will be known? It will be known by goodness of fit index. Some indices are there. Some indices are there. I will explain later on. Some indices are there by which I can say this model is fit. Fit means fit to which? Fit to the data. The data you have collected. That means you have data means measurement. You have done the measurement. See, for this variable you have taken 3 items. For the variable you have taken 4 items. For this variable you have taken 5 items. Likewise, you have measured a particular construct. Measure the particular construct means you have some data. That means this is a model. That means how much the model is fitting to the data. This is the basic question of ACM. How much this model is fitting to the data. This is the basic question in ACM. How much it is fitting? More will be the closure of input matrix, input covariance matrix to the output. Sorry, more is the closure of output covariance matrix to the input covariance matrix. More will be the fitting of model to the data. How it will be known? Some indices are there. So these are all popularly called as goodness of fit. So many indices are there. 5 to 10 important indices are there. I will discuss later on. Do not worry. So I will not go to any other thing because time is going ahead of us. I will go to that. Look at here, assumption of ACM. Strong assumption. It is another differentiation between PLS ACM and covariance based STM. Least square based SCM and covariance based STM. This is the most important difference. Some strong assumption need to hold good in case of covariance based SCM. That we will do in the Amos. No outlier. We are assuming that no outliers are there. If outliers are there, our model fitting will be weaker. No multicollinearity. What is that multicollinearity? In the regression, what we are doing, the software will give you the relationship between independent with independent and independent with the dependent. But researchers' interest is there independent to the dependent. So the relationship between independent variable with the independent variable is causing a problem. And this problem is nothing but the multicollinearity, which is an assumption in your multiple regression also. Anybody who has adopted in any research multiple linear regression, this assumption is most important. Multicollinearity, no multicollinearity. Because multicollinearity unnecessarily exaggerate your adjusted R square. Your adjusted R square is saying stronger relationship between independent and dependent, independent and dependent. but the analysis result will give you as a whole the relationship between independent and dependent, independent with independent. So the relationship between independent with independent is assumed to be very less or negligible. And this negligible relationship is taken as an assumption that is no multicollinearity. Multicollinearity is a problem for multiple linear regression. It is because linearly related every variable with a construct in the ACM also multicollinearity is an assumption. Please try to understand. Anybody who has adopted multiple linear regression in the research, they must be taken this assumption. This assumption must hold good. That means this assumption must not violate in the multiple linear regression. If this assumption will violate, then there is a question mark on the adjusted R square value. There is no use of value of adjusted R square. There is no use. Adjusted R square is 0.6. You are saying attitude has 60% influence on satisfaction. There is no meaning of 0.6, yani 60% if your multicollinearity is high, because multicollinearity is a issue of relationship between independent with independent. But you are serious regarding relationship between independent with the dependent. I hope I am clear now. Then multivariate normality. Generally, you are taking your data is normally distributed along with the error distribution. So this is what multivariate normality. Multivariate normality is saying not only your data is normally assumed to be normally distributed, but also the error term is normally distributed. If error term will bank upon a particular variable more, that means other variables has the less influence. That means common phenomenon they are sharing with each other to come under a particular construct is any question mark. Try to understand. So multivariate normality assumption must hold good. Multivariate normality assumption must not violate. Simply right now you understand data is assumed to be normally distributed. This is the normal statistics you are discussing from +2 level. Even nowadays from matriculation, population is assumed to be normally distributed. We are writing in the answer whenever we are attending the question answer in the examination. Whenever we are attending any question answer in the examination, before doing any exercise or any solving any problem and putting the formula of regression or ANOVA, what you are writing? We are writing population is assumed to be normally distributed. Here you are taking sample. So data is normally distributed. Very simple. So here in the ACM also this assumption must hold good. And ACM is talking about not your linear relationship. Linear. See, this is the construct. These variables are linearly related to the construct. Number one, these variables are linearly related to construct. And this is the suppose attitude. Simultaneously, attitude is influencing satisfaction. Simultaneously, attitude is reflecting satisfaction. This is also a linear relationship. Simultaneously, the satisfaction is influencing the performance. This relationship is also linear. And this is what called as structural equation modeling. You have measured the attitude separately. You have measured the satisfaction separately. You have measured the performance. Now you are testing whether this model is performing, whether this model is fitting to the data or not. All the relationships are linearly related. We are assuming if non-linearity exists, then there is no application of ACM at all. Linear relationship is an assumption that must hold good, and it is related to the variable x1, or in the questionnaire it is the item x1 is related to construct A linearly, not related to suppose attitude. I am saying attitude have three components. Your tri-component model of attitude is saying cognitive, cognitive, affective. So it is cognitive. Suppose cognitive, another three variables or items. Affective, another four variables. Suppose another four variables. Suppose cognitive, affective, another four variables. Now all the three constructs are forming attitude. all the three constructs are forming attitude. Attitude is influencing satisfaction. Satisfaction is influencing performance. Now, these construct cognitive, this construct cognitive, this construct or latent variable, you can say construct or latent variable of factor that is affective, are measured. Suppose you will say the variable x1 is also related to this, is also related to this, then the assumption 7 is violated. Try to understand. Later on in the practical sense, I will make you understand this is what called as cross loading. So there is a unidimensional construct, even if it is loaded on here or loaded on here, it is negligible. It is loaded on this construct magnificently. So I have taken, researcher have taken x1 under A, not under C or another B. I hope all of you are clear. Assumption of ACM. I hope all of you are clear. All of you are clear, I hope.
Yes, sir.
Yes, sir.
Any doubt till now? Any doubt till now?
No, sir.
I'm in doubt whether I am going in the right direction or not. Am I going in the right direction? My speed is okay, or it is more, or should I slow it down, or should I give
No,
any
sir,
more
it's
example?
okay, sir. It's okay, sir.
Speed is okay, sir.
Okay. So now coming to, these are all the symbols we will use in the Amos. Please look at here. So this is what latent variable. The what is that called as a circle, not exactly circle. This type of symbol is latent variable. That means it is unobserved variable, unobserved variable, or factor or construct. Just now I was using these three terms simultaneously. And this is what observed variable. That means whatever measurement we are doing through the questionnaire, the values will be put here in this type of rectangle or square. So this is the observed variable. The exact symbol you have to take in the Amos. Try to remember. So many symbols are there. I have taken only 4 important symbols. And this is the direction. That means the moment I say attitude leads to satisfaction, satisfaction leads to performance. This is single arrow. Suppose I am saying these are the 4 items or variables constructing attitude. So these are all the 4 items constructing attitude. Look at here. That means there is a covariance exists between these. There is a covariance exists between these these items. There is a covariance exists between these items. Try to remember. And this is what the double-headed arrow. Look at here. Clear now? Clear now? Clear now? Yes or no?
Yes.
Yeah, please say something, sir. Answer. Otherwise, I am thinking that I am going out of order.
No,
Sir,
sir,
if you
no, sir.
can
We are
repeat-
just writing, sir.
Sir, double arrow. If you can repeat double arrow again, please.
Okay. See, double arrow for the covariance or association.
Okay.
I will explain. Do not worry. I will explain. Do not worry.
Okay.
So look at here. The moment we will open the Amos Graphics, such like thing will be open. The moment we will open the Amos Graphics, such like thing will be open. Look at here. Please have attention. So look at here. So this is what latent variable, which is unobserved. That means whatever questionnaire measurement we are taking, we will put here, not here, not here. We will put here. So this is what they call manifest variable or observed variable. And this is what, look at here, latent variable. And look at here, it is path icon. That means regression. And this is what error. That means you can manually do this upon this. Look at here, you can manually do this upon this. I will show you, do not worry. This is the error term. So many things. This is the cut. This is the cut. Just say cut paste. This is single selection. This is simultaneous selection. And this is move. Trot is move. Once you select all, you move. I will show you everything. Do not worry. It is move. And it is copy. It is rotating rotating any model to different direction. It is resizing the value of parameters. It is making the beautification of the model. I will show you how model is beautified. And this is analysis. All these things are there in the above analysis also. Do not worry. These analysis are there in the analysis property also. Do not worry. And this is what copy. This is what copy is. Sorry, save. I'm sorry, save. This is what copy. This is what copy. This is what save. And these are all as usual. Zoom in, zoom out likewise. I hope all of you are clear till now. So this like figure will be opened the moment Amos Graphics will be opened. All of you are clear till now? Clear?
Yes, sir. Yes, sir.
And this is what process of ACM. What is the process of ACM? This ACM process will be more extensively clarified the moment I will analyze through ACM in the last session of mine. Do not worry. So first you specify the model. As I specified the model, by taking 4 items under attitude, I have specified the model here. Look at here. This step I was explaining you. I have specified the model. And the model is identified now. Who will come under whom? Suppose I have specified that attitude will be measured in 3 different ways: cognitive, cognitive, and affective. This is specification. X1, X2, X3, X4 will come under cognition. X5, X7, X8 will come under cognition. X8, X9, X10 will come under affective. And this is what called as model identification. I have identified the model. If I have identified the model, and now I will collect the data accordingly. That means I will administer the questionnaire. Now I will measure the model fitting. I will justify model fitting by model fitting index. If not, again I will re-specify the model. If not, again I will re-specify the model. Once the model fitting is done, I will interpret the estimates. How much model is fitting? How much reliability is there? How much validity is there? So can it be replicated in other country, other industry or not? Here all the interpretation will be done and a result will be reported. This exact figure is there in the book Klein. This is a very famous book of ACM. This exact figure is there in the book Klein. Am I clear now? Am I clear till now?
Yes, sir.
Am I clear till now?
Yes, sir.
So look
Yes,
at here. So look at here. The moment we will prepare a model in the ACM of a model of ACM in the Amos Graphics, this like model we will prepare. Once we test, this regression weight will be given to us. So this is the input model. This is the output model. This like model I will create in the Amos canvas. I will create in the Amos canvas this like model. Once this like model is created, the data will be incorporated here. The data will be incorporated here. Then I will test. Once I will test, it will give me the test result. So it is the output model. So it is the output model of Amos Graphics. In the Amos Graphics canvas, and these things will be appear. Do not worry at all. These things will be exactly appear in the Amos canvas. Am I clear till now? Am I clear?
Yes,
Now
sir.
this,
Yes, sir.
this is the benefit. Time is there. Am I getting you bored? No, time is there. So benefit of ACM, as I said earlier, in the traditional case, what we are doing, separately we are analyzing the factor analysis, separately we are doing the regression. Now both of the things will happen simultaneously. Now exactly a theory can be tested. Key Hochberg T-factor theory is hold good in the telecommunication industry in India or not. In order to motivate the employee of telecommunication industry, Hochberg two-factor theory of motivation is holding good or not. This exact theory can be tested, which was impossible in other statistical technique. See, any question anybody is asking? Okay. Now suppose anybody, I have done a research on suppose motivation, or suppose what is that buyer seller interaction. Some factor I have taken buyer seller interaction effectiveness, and you are replicating that. You will confirm ki yes, SARS measurement is accurate in other state also. That is confirming. This confirming is possible in case of ACM also. So the confirmatory factor analysis. So popularly we are saying the ACM is nothing but a combination of confirmatory factor analysis and regression, multiple linear regression. Although so many other multivariate statistical techniques are involved. So that is the reason we are saying structural equation modeling is a family of statistical techniques. And the most important two statistical techniques are confirmatory factor analysis and multiple linear regression. And results are derived and analyzed in a more reliable way because of measurement error. This measurement error is most important. If the measurement error is lesser, more is the probability of replicating the same research in other context. If reliability is less, error is more, lesser is the probability of replicating the same research in other context. So this is the benefit of ACM. So many other benefits are there. Time is very less. I hope some of you are, if some of you are already introduced to the ACM, they might be getting bored. So directly I will take you to the Amos Graphics. Am I clear? These are all references. Let me end this show now. Let me end this go. Now I will go to the, should I go to the Amos Graphics? Should I go to the Amos Graphics?
So one thing, sir.
Yes, sir.
Can you please send us your PPT or this PDF?
All the PPT will be given to the organizer and they will share to you. Do not worry.
Okay.
Clear? All my PPT of all my class, all the PPT of my all classes will be shared to organizer. And for tomorrow session, I will give a data sheet also to practice at your end. Please be ready with Amos. All of you have loaded Amos in your computer. All of you have loaded
Yes.
Amos.
Yes, sir.
Yes, sir.
Okay.
Yes.
Yes, sir.
Okay.
Sorry.
So
one question was there.
tell me. Tell me.
So one
Tell me.
question. Any kind of model, if I try to use Octapace or any model in any situation, can I test it with SEM?
Yes, very much. See.
Okay, just we
tell
need
me,
to gather
tell me.
the data, prepare the questionnaire, because all the instrument of these theories have a reliability and validity tested instruments. So we run it in the organization, get the data, put it on the Amos, and then we can get the results, right?
Definitely. See, for that purpose, rightly we are saying Octapace model. If you are taking Octapace model, who has done this Octapace model prior to you? If you are getting that scale,
Okay.
I will say tomorrow, do not worry. Who has adopted that scale? Scale means questionnaire.
Yeah,
If you are
got it.
if you are directly taking the scale and he or she has adopted in the same industry, the industry on which you will adopt, then you will simply adopt that and calculate the reliability. Matter is over, then come to this Amos. If in different industry, different country, that means research context is changed. You have to analyze the reliability, validity, everything. So two methods are there. One is scale adoption, one is scale development. If others scale you are adopting, directly straight away we will go to the Amos, because in the Amos reliability validity is there. If you are developing a scale, the scale will be reliable and validity fast. Scale validity reliability need to be judged fast. Then we will go to the Amos. Got my point, madam?
Yeah, sure, sir. Thank you so much.
Sir, I have a question here. If we are adapting a standardized scale, but that is not in Indian context, so then we can go directly with SEM, or we'll do the validity and reliability in Indian context and then we do it on Amos.
Now, please clarify two questions. Are you adopting the exact items without any changing?
Yes, sir.
Number one. Number two, are you adopting in the same industry?
Yes, sir.
Then you need to test the reliability first.
Okay.
Because because the context is changing.
Okay.
But
even time is changing.
But you need not to make a test retest because you are adopting exact by your item. There is a
Okay.
test retest. There is a test retest. There is a face validity. There is a content validity. These are
Reliability
all.
test.
Madam,
And if the yes sir, I got it.
there is a face validity, there is a content validity. These sort of thing may not require in your case because exactly same items you are adopting, but reliability, internal consistency is required because the context is changed. Are you getting my point?
Yes sir. And if the industry is changed, like for example, the
concentration.
same test is given, is already tested on healthcare industry, and if I wanted to run the same test in the manufacturing, so there also I need to do the reliability
Yes,
test.
reliability is
Yes,
must. Reliability
reliability
is
would
must.
be test.
Okay, with the same
Why?
question.
Please try to understand what is the reliability saying. One famous example, suppose a book I will exactly divide it into two parts. Book ko मैं फाड़ दूंगा. Is that right? Now I will take the consistency of half, your first half and second half. Then again, suppose it is a 400-page book. I will make it 200 each. I will test how much of average score of wordings are there. Then again, I will divide into 100, 300. I will divide it to 150, 250. If the average score is same or near about similar, then I will say it is reliable. So that is what called as split half test. Split half test.
Okay, fine.
Sir,
Sir.
please tell
So
split
try,
test.
please hold on. So the reliability you are testing by Cronbach alpha, the reliability you are testing by Cronbach alpha is nothing but the internal consistency, which is required in every case. But the face validity, test retest, content validity is not required if you are taking directly the same items. Am I clear? Am I clear?
Yes, sir, but items we are what I mean to
Yes,
say,
sir.
items we are taking as it is, but only there is a difference in the industry. It is valid and reliable instrument in Indian context, but if the industry is changed, then we'll do the same.
I got your point, madam. I got your point. Still, you have to test the scale reliability first. Because the scale reliability is talking about internal consistency of items.
Okay, so we will go with back
and model validity automatically, if you apply the ACM, model validity automatically will appear in the ACM.
Okay.
Got my point, madam?
Okay.
Yes.
Okay. Sir.
Yeah, sir. Yeah, sir. Clear.
Okay. So I'm going to Amos Graphics now. Clear? Yes. So all of you, please open the Amos Graphics. I'm going to my PC. How can I adapt here? Unless and until I will stop sharing. Dear participant, my screen is visible to all.
Yes, sir.
Yes, sir.
Look at here. This is already a done. So let me go to a new platform. So please open your Amos Graphics. All of you, please open your Amos Graphics.
Yes, sir.
So software screen is open. Software screen is open. Yes or no?
Yes, sir.
Yes, sir.
Are you along with me? Please answer somebody. Are you along with me?
Yes, sir, we are with you.
Yeah, yes, sir.
Yes,
But,
sir.
Yes, sir.
Now,
your voice is not clearly audible, sir.
Sir, it
Not
is
clearly
echo
audible.
is coming. Echo is there, sir.
Yeah, one should be muted, sir.
now it is okay.
Yeah, yes, sir.
Still it's coming. Yes, sir.
Please give me 1 minute. Please give me 1 minute. Now it is okay.
Yes, sir.
Yes, sir. Yes, sir.
Still echo is there.
The echo is there, but it's audible.
Let me close the laptop. I hope it is okay now. It is
Yes,
okay
Yes,
now?
sir. It is very
Sir,
clear
now
now.
okay, sir.
Yes, yes, sir.
Okay, okay. So look at here, coming to the latent variable first. Look at here. Please click here. All of you have opened the Amos Graphics. Such like Amos Graphics will be opened. Have you opened?
Yes,
I
sir.
hope organizer has given you the link. I hope organizer has given you the link and you have downloaded
Yes,
the
sir.
Amos.
Yes, sir. We do have.
It is because Amos is a paid software and the link is mostly a pirated software. So I am not operating here how to install. So that is the reason I have requested the organizer in the background. In the background, you need to install it. I should not say you how to install because it is pirated. Clear?
Yes,
So
sir, yes,
so anybody has not installed, I am sorry for them. Please install for tomorrow session because tomorrow is very important for CAP. Okay, those who are opened, look at here in this the circle like things, you please click here. So the moment you put the cursor here, it will show you what it is. Look at here, on observed variable. That means latent variable. Draw on observed variable. Please put your cursor here and it will show you draw on observed variable. Now I am drawing. Look at here. I am drawing the on observed variable. Done. Done. Now look at here. It is showing. Now it is showing observed variable. Click here and take here. Suppose I am taking 3 observed variable or 4 observed variables. Look at here. Suppose I am measuring the attitude by 3 components: cognitive, cognitive, and affective. First component is a latent construct which is unobserved, and we are observing by these 4 variables. So let me connect here. Look at here. Let me connect here. Let me connect here. So this is one construct, that is cognition. So again I will come here. I will draw another construct. So this is cognitive. And let me again come here. Suppose cognitive I have measured. Suppose cognitive I have measured by 3 construct. Suppose cognitive I have measured by 3 construct. 3 items. That means 3 indicators. In the Amos or in the SCM, the popular term is indicators. These are all indicators. Or we can say exogenous variables. Mostly we are saying these are all indicators, or these are the latent variable or construct. This is latent variable or construct. Now let me connect, sorry, let me connect here. Let me connect. See, this is the thing, it is reflecting, it is a reflective measurement, not formative. It is reflected by this. Do not worry, reflection formation will be clarified in my 4th session. So another construct I am creating, that is affective. That is a tri-component model of attitude. It is cognitive, it is it is cognitive, it is cognitive, and it is affective. And affective is measured by 4 items in my questionnaire, sorry, 5 items in my questionnaire. Suppose affective is measured by 5 items. Affective is measured by 5 items in my questionnaire. Is measured by 5 items in my questionnaire. So I have taken here, look at here. See, the moment you will draw, it will be highlighted as red. Unless and until it is highlighted as red, it is not activated. And the moment you will draw and drag here, it will also highlighted as green. Look at here. So it is activated. Now clear. Now clear. Got my point? All of you have done this much of thing? All of you have done this much of thing? Or yes or no? Yes or no?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes,
Doing,
sir.
sir. Doing, sir.
Yes, sir.
Should I give you 1 minute?
Yes, sir.
Please do. Please do. Please do. Do not worry. So this is the basic thing. You must have patience to understand fast. Otherwise, the further session will be more difficult. So what you are saying, where the role of error comes, again I am explaining. See, let me name it. Let me name it. In order to name it, make a double click here. Simplest way I am saying. In order to name it, let a double click here. Suppose it is x1, it is x2, suppose it is x3, suppose it is x4, and suppose it is cognitive. Suppose it is cognitive. Suppose it is cognitive. All of you are clear? Have done this much of thing? See, what is the fundamental statistics? Statistics is saying in Amos, in covariance based SEM, the amount of variance the x1 is explaining from cognitive is not in total or is not full. So the amount of variance which has not been explained by x1 for cognition is the error. I repeat, the amount of variance could not be explained by x1 for cognitive is error. Likewise, the amount of variance could not be explained by x2 for cognitive is another error. Likewise, the amount of variance could not explained by x3 is another error. And the same is the case for x4. So our duty is to add a error term. So look at here, it is the error term. Look at here, look at my cursor movement, it is the error term. Look at here, it is the error term. Click here and put here. Click here and put here. So the error term has been added. Error term has been added. All of you have done? Error term has been added.
So can you repeat sir the error term sir again?
Yes. Do not worry. So I'm adding the error term here also. So you will be knowing. Look at here. Just click here. Then come here. Then click here. Error term. Click here. Click here. Click here. Click here. Error term. Clear? So now I will show you another operation. I will drag here a truck symbol here. There is a look at this truck symbol. So you can drag and put here. You can drag and put here. There is a truck symbol. You can drag and put here in order to make the beautification. So many other things are there. Do not worry. So many things are there for beautification. So many things are there. In order to make a clarity, I'm doing. So again, I'm repeating. Look at here. Click here. Look at here. Look at my cursor movement. Click here in the error term. Now click here. Click here. Click here. Now error term has been added. Now error term has been added to every items or we can say every indicators. In the questionnaire we are saying items, here we are saying indicators. Here we are saying indicators. Are you all clear? Are you all clear? Clear?
Yes, sir. Yes, sir.
Yes, sir.
This
So,
much you have.
one thing, sir. Sir, I could not rotate this error term, sir, as you have rotated.
Troc. There is a troc symbol. Click there in the troc symbol. There is a troc symbol. Look at the troc. Move object. It is written.
Yeah.
Click
yeah. Okay. I clicked in a different symbol. Yes, sir.
Done it. Done
Yes,
it.
sir. Done it.
See, this is the beautification. Look at here. This is a pen. Click here. In the pen mark, click here. Then click here. Beautification done. Look at here. Beautification done. Done. Done.
Wait,
Beautification.
sir.
Done the beautification.
Means this pen is to be. Yeah, pen. What is to do?
To make the adjustment
With the help of this pen.
To make the adjustment for the graphics. Look at here, click here, and
yes,
then click here.
Yeah. Okay.
Let me, suppose I'm showing you again. Do not worry. Suppose.
Okay. I click there. That means if some noises are there, then it removes this noises.
Look at here. Let me show you again.
Yes, sir. Done it, sir.
Look at here. Again, I'm doing. Now it is not.
Yeah, sir. Got it, sir.
Done it.
Got it, sir. Yes,
Okay.
sir. Done it, sir.
So do not worry.
Means,
so many symbols are there. Gradually, I will say everything. Do not worry at all. Clear? All
Yes,
of you clear?
Yes, sir. Yes, sir.
The moment we are doing manually all these construct, this is a construct, and these are underlying 4 indicators. That means this is a model. That means this is a model to be confirmed. It is a measurement model. It is a measurement model to be confirmed. But directly we can make the measurement model. Directly we can make the measurement model. How? I will show you how. For the sake of showing for the beginners, I have done. Directly we will make the measurement model. See, there is a symbol like scissor, kaichi. Take here, and I'm cutting it here. I'm cutting it here. So directly I will make the measurement model. Look at here, there is a tree-like figure. Draw a latent variable along with indicators. That means simultaneously the entire thing will be drawn. Look at a tree-like structure. All of you could see. Or yes or no?
Yes, sir.
Click here and click here and come here. Now first draw a latent variable. Drawn. Now just go on clicking the number of items you require. Suppose number of items I require here 3. 3 times you click here. 1, 2, 3. Done. At a time. Clear? Clear? Suppose again I will cut it here.
Please repeat it.
I'm repeating. I'm cutting it here. I'm repeating the third construct. Third construct is made up of 4 items or 4 indicators. So first click here. Okay, look at here is a trick-like structure. Click here. Come here the Amos canvas. Then draw the latent variable and the number of indicator you want to add. That number of time you need to click. So I need to add 5 indicator here. So I need to make a 5 click. 1, 2, 3, 4, 5. Done.
Done, sir.
So suppose again I'm cutting by taking the scissor here in order to make the beautification. There are so many ways are there. So I'm taking here. So this construct is made up of 4 indicators or 4 exogenous variables. So 1, 2, 3, 4. Done. All of you done up to this moment?
Yes, sir.
Yes, sir.
So now I need to draw it in a beautified manner. what I will do, I will rotate. Look at here. So this is the rotation. Look at here. Look at here. This rotation. Rotate the indicator. It is written. So entirely I am rotating. Entirely I am rotating. Look at here. 1, 2, 3. Rotate. Done. Rotation. Done the rotation. Again I am rotating. I am rotating. Now what I will do now, I will.
Oh, sir. That means, sir, we have to cut the manual part first.
Yes.
Then only, yeah, then only we can rotate. Otherwise, we cannot rotate.
Yes. So look at here. I am now taking this thing as a whole here. See what I done. I have selected every individual. So this become a single unit. Then by the truck, I have drag here. Clear? The same way, I will deselect. Then I will go for select. Select. I'm selecting every individuals. I'm selecting every individual figure items. I'm selecting now. So that what I will do, I can take the entire figure at a time. I can take the entire figure at a time. Now look at here. I am dragging the entire figure at a time. I'm sorry. Again, the thing has not been done properly. What has happened? Acha. Another thing has not been selected. Another thing has not been selected. Now it is done. Now I'll take the entire thing. Done. All of you done this much? All of you done this much?
Sir, please repeat.
See, in order to take the entire, in order to take the entire figure, yani ki entire measurement model, you need to select everything of that model. See, it is select one by one. If you select this, it will be selected all. This is all selected all. Now I will take all the things at a time. Dekho, look at here. Look at here. Clear? If you want to if you want to take one by one, you need not to select all. You need to select one by one. First, let me deselect. It has been deselected. You need to select one by one. See, one by one, I am selecting everything. Everything you need to select. Otherwise, it will create problem. You need to select one by one everything. Now, apart from rest of the two measurement model, you can drag and drop anywhere this measurement model. Now look at here. By the truck symbol, I am drawing only this model is taken everywhere I want. Only this model I am taking everywhere I want. Clear? If I want to take every model simultaneously, then I need to select all. Look at here. This hand mark is selecting all. This hand mark is selecting all. All thing has been selected. Now by the truck, I can take anywhere all the three. All the three. Now if I will rotate, all the three will be rotated. Look at here. All the three will be rotated. Sorry, one by one. Rotation will be one by one. Clear? Done? Till now, this much is done.
Sir, individual selection is done by the first hand, right?
Yes. You
so
put your cursor. You put your cursor, it will show. Look at here. Select one object at a time. It is written. Look at here. Select one object at a time. Put your cursor, it will show you. The next hand mark you put, select all object. It is written. Select all object. Clear? The next the next hand symbol is showing deselect all object. Now I am deselecting. Look at here. Once you select, it will be highlighted by blue mark. I am now deselecting. Now look at here. Now highlight of blue mark has been removed. Clear? Still rotation is activated. So if you do not deactivate rotation, everywhere it will be rotated. So the thing you are activating, you need to deactivate that so that you will go to other operation. So that you will go to other, you can go to other operation. All of you clear? All of you clear? Now,
yes,
suppose now suppose you want to add so many other figure, you need to resize. It is the change the shape of the object. Look at here. Look at the flower mark, sunflower like mark. It is written. Look at here. change the shape of the object. Click here. Now you are changing. Now look at here. The more the exact shape I want to be, I can make the change. Clear? Suppose so many figure you want to add, then you need to small it, make it small. Suppose some less number of figures are there, you need to make it large, as much as large. Clear? Clear? So this is the sunflower like figure, small, and the moment you put your cursor here, it is written change the shape of the object. You done it? Done it till now? Done it till now? Now what you need to do is you need to mark it. See, please,
Sir,
tell me.
how to undo it if something went wrong? Maybe I don't want to resize, but I did it for one. How to undo the function?
Undo
I'm
means
trying to.
you need to cut it completely. You need to make it again. You need to cut
Okay.
it. That is a scissor figure. Scissor. You need to cut it completely.
Okay.
So look at here. I am cutting it completely. That is a scissor figure. Again, you need to make it clear.
Okay.
Is that done? See, please, all of you.
I
Last
think Control Z works, sir.
Control Z works, but to some extent. Control Z works, yes, but to some extent. Somebody is asking some question, madam.
Sir, in the end, I think there is a undo option.
That is an undo option, but that is activate to some extent. That means one or two step. That means one or two step undo, not all the step undo. Clear?
Sir, I'm asking one step before. I mean, one step only.
Then there is an undo option. Look at here.
Okay.
At the bottom, undo the previous change. It is written. Look at here. Look at my cursor movement. Undo the previous change.
Okay. Yes, sir.
There is a reverse arrow mark. There is a bend down reverse arrow mark. The moment you put your cursor here, it will showing undo the previous change. Clear?
Okay, sir.
Okay, do not worry. Gradually, all the symbols will know. See, the most important last thing I'm saying, these square size or rectangle size boxes are meant for our data. The data we have collected through questionnaire. And these your circles, large circles are latent variable, which are unobserved. We are observing, we are estimating through the indicators. So that is the reason the very meaning is latent variable or construct or factor. Latent variable or construct or factor are measured through indicators. So these are all indicators. Look at here my cursor movement. And this is latent variable, and these are all the error term. These are all the error terms. Look at my cursor movement. These are all the error terms. So these square or these boxes, rectangle boxes will be filled by our data. These rectangle boxes will be filled by our data. All other circles we need to fill by some name. Suppose I am naming it. Look at, make a double click here. Make a double click here. Such like a box will open. Such like box will open, and you name it. You name it. Suppose it is cognitive. Suppose it cognitive. Now you name it another one. It is suppose affective. Affective. Suppose it is affective. Now close it. Let me reshape, because it is not incorporating all. Let me reshape. Reshape ho gaya. Now what I need to do, these unobserved variables need to be taken into consideration. This is unobserved variables. See, look at here. Do you have the time to proceed for 5 minutes, or should I stop here, all of you?
Yes, sir. Yes, sir. We have time.
Okay. See, suppose these boxes will be incorporated by your data, but right from now, in order to make you understand, I am naming it. Do not worry. X1, X2, X2. Sorry. X2, X3, X4, X5, X6, X7, X8, X9. Done. Now I need to name the error term also. Again, the same process. Make the error term E1, E1. Sorry, let me make it small. E1, E2. You can do it, but there is a help to you. Instead of doing this, you can directly name the unobserved variables. The error terms are unobserved variables. Look at here. Go to the plugin. Go to the plugin, all of you. Go to the plugin. All of you, please go to the plugin. Done? Done, all of you?
Yes, sir.
There is a term called as name the unobserved variable. At a time, all the unobserved variable will be named. That is a term. All of you got it? Name the unobserved variable. Look at my screen. Name the unobserved variable. All of you
Yes,
find
sir.
out. Now
Yes,
click
sir.
there. Now click. If you click there, all the unobserved variable will be named automatically. Look at here. It has been named. Clear? It has been named. You can do manually, one by one. You can do simultaneously. But what is happening? I have drawn this fast. Then I have drawn this. So this is the reason E1, E2 have started here automatically. Software has started it E1, E2, E3, E4, 5. Then E6, E7, E8, E9. All of clear? You can do manually. You can do here. But try to remember, these square size boxes are meant for our data. I will tell you tomorrow. Clear?
Oh,
So this can you repeat once again, sir, the last?
Okay.
So the
So
connector
one
that
thing,
you
sir,
give.
while putting plugin unobserved
Ah.
variables, then automatically they will name as F1, F2, F3, etc. Sir.
E1, E2, E3, because these are all error.
Yeah.
These are all
E1,
error.
E2,
So you,
E3, and F1, F2.
if these thing you will not incorporate, it will be taken. It will be taken as F1, F2.
F1 or F. Okay.
If these circles you will not name it, it will take F1, F2. Okay. Let me test you. Cognitive. Suppose now everything has been filled in. Only the error term has not been filled. Go to the plugin. Then name the unobserved variable. The madam who was asking for repeat, I am repeating. Name the unobserved variable. Done. Clear? Suppose you have done it, but
Yes,
these
sir.
two, suppose you have done everything except these two circles. Except these two circles. Suppose now if you go for unobserved variable, what is happening? Look at here. Name the unobserved variables. Rightly, sir was saying F1, F2, because these are all the factors or constructs. Automatically, it will take F1 and F2. Done, all of you? Done, all of you?
Yes, sir. No. Yes, sir.
So tomorrow we will go directly to the application of CFA, conformatory factor analysis, and we will move ahead. And today I will share a data set of one of my scholars, PhD scholars data set I will share today. So we will practice CFA on the same canvas tomorrow. Clear? So all of you,
Okay,
anybody who has not installed, try to install this Amos software, without which the workshop has no meaning. Only you will know the theory, you cannot practice. I have the patience to practice along with you for so much time, but provided the organizer need to give the time, and you should have the patience. I do believe till now so many participants might have been left. Only 26 participants are some are there. How many participants are there till now? So many participants has already left.
40, we have 48, sir, now.
Because
48.
this was
40, sir, 40 number.
this was
48.
I was suspecting. Out of more than 100, only 48 are there. So anyway, I do not know what is happening. So please collect their
maybe, sir, actually the program was scheduled from 4 to 6 and it has been postponed to 5 to 7. That's why they may have some other consignments, sir. That's why they may go, sir.
Okay.
I think, sir. I think. I don't want to advocate.
Anyway, still
We need
tomorrow,
to take the data and see.
but still tomorrow the same 5 to 7, and the day after tomorrow onwards again 4 to 6. Do not worry.
Sir, may I ask you one thing? These diagram, this diagram always we have to prepare it manually, or can we draw it directly? Is there any automatic option
for everything? For all
Yes,
the
sir. Okay.
all the factor, no. For all the factor, so directly you can do it. This particular construct you can do it as much as you can do it
Okay,
as much
sir.
as. But all these things simultaneously, how come it is possible? Because you may require 3 construct, I may require 5 construct. How the software
Okay,
will
sir.
know who will require how much constructs?
Yes,
The
sir.
larger will be the circle, the larger will be these boxes also. This is the problem in simultaneously doing. If you do manually, then this thing will not happen. Suppose look at here, I will make a larger here. The larger will be the boxes likewise. Clear? So
Yes, sir. Yes, sir.
this much only can done be simultaneously or automatically. Rest all the thing you need to do manually. Clear?
Yes,
All of
sir.
you clear? Okay.
Sir,
today,
one thing I missed actually.
Thank you so much,
tell me.
sir.
Tell me.
Sir, that stamp symbol, can you just tell me what is the function of that? I missed
Which
that
stamp?
one only.
Which stamp?
That 6th one.
Are you talking about selecting or deselecting or moving? Regarding
No,
which
not just if you go from the beginning, the 6th one.
One.
I
arrow,
think
arrow.
the error symbol. Error symbol.
Yeah, error.
Oh, error symbol. If
Yeah,
you are doing if you are doing if you are doing manually, then it is required. If you are doing simultaneously, it is not required. Suppose I am doing manually, I am taking a latent construct, then I am taking the indicators, then I am connecting the latent variable with the indicator. If I am doing, then this error term is required. If you are doing simultaneously by this symbol, draw the latent variable along with the indicator, then it is not required. Clear?
Okay. Got it. Thank you, sir.
See, another thing is there. Suppose exactly the same thing you require. Simply make it duplicate the object. Look at here. The 10th object, duplicate the object. Exactly the same thing will be duplicated. Look at here. Exactly the same thing will be duplicated. Suppose you want to duplicate everything. Suppose I'm selecting one by one. Let me select the simplest one. Select everything. The entire thing has been selected. Now I'm duplicating. Look at here. Exactly the same thing will be duplicated. Look at here. Duplicated. Done. Got it? Okay. So this much from my end today. So tomorrow we will do the same thing in the CFA, confirmatory factor analysis. Little bit disheartened because of the attendance. I do not know what is the problem. Okay, let it be. Tomorrow tell them to attend. Dr. Baroda, now you can move ahead.
Yes, sir. I'll inform everyone.
Move ahead. This much from
Thank
my
you.
end.
Thank you, sir.
Due to some technical issues, Baroda not here.
Thank you, sir. Thank you. I'm here.
So thank you, sir. Have a nice interaction
Thank
with
you,
the
sir.
participants.
Thank you, sir.
Thank you all of you.
Thank you all of you.
Thank you, sir. Thank you, sir.
Thank you.
So tomorrow, please, all of you install the Amos.
Yes, sir, definitely.
Okay. Thank you all.
Thank you, sir.
Thank you.